Hello coders, welcome to my channel Radhe Radhe. In the lecture number 5, we are going to discuss the two questions from the two pointer. As I have said in my last class that from today onwards, as I will start taking the questions from the medium level. So here we have the two questions from the lead code. The first question is the four sum question. It is just same like the three sum question that we have discussed earlier. Here we just need to check the sum of four numbers from the array and check that if it matches the target, then we will return that number, that as a number. So let's study what let's see what the question saying. So we have given an array of n integer, return an array of all the unique quadruples nums a, nums b, nums c, nums d such that a b c d in between 0 to n and A, B, C all are distinct. It means, like you can see in this case that we have given nums 1, 0, minus 1, 0, minus 2, 2, and the target is 2. So we have to find four number from here such that it will matches the condition that if we summing all four, it will gives us the target 0. We cannot sum A and B itself because A and B and C and D all are the distinct one. So we will take 1, 0. We can't take 1 and 1. So means all are distinct, it means. So here you can see that if we take minus 2, minus 1, 1, 2, it gives us 0, like minus 1 minus 3 and 1 2 3 to minus 3 plus 3 equals to 0. Same way here is also the same thing, and this is also same thing. So yeah, these are the three quadruples, and all are unique because we have said that we need unique one. So it's a simple thing. We will just use the set to we will just use set to give the unique answer. So it's not a big deal. So the big thing is the main thing is that we have to discuss the approach. And approach is quite similar, just like we have done in the threesome problem. We will take I, J, K, L as four number and see if it matches the target. Then yeah, it is one of the quadruple, and we will return it. So now before going ahead, as we know, we will start from the brute force approach. So let's see what the brute force approach is. So yeah, in the brute force approach, we will use the for loop, like, because we need four number. To the simple, we will use for loop and such and consider all the elements one by one. Like here we have given like here we have given number. What the number is? 1 0 minus 1 1 0 minus 1 0 minus 2 2 0 minus 2. So what we will do, here it is plus and this is minus 1. So what we will do, we will take I here, J here, K here, and L here, and we will move first, we move L and check. We will take I, J, K, and L will be moved first. In first case, I will move be pair with this one, fit then this one, fit then this one. If and this way, if it completes, then K will be moved. So it means simply the for loop will be used, and it will take all the four quadruples. So yeah, we are using four for loops. So so the time complexity will become of n to the power 4. So and if it's a constant, maybe it fast the case cases, but it is not the efficient one. As a we know that in our in the in we want only uh, optimized solution, and this is really not an optimized one. So we will see the optimized, which will be done with the help of two pointer. So what we will do, we will take three loop. We will take the three loop that will indicate like we have given 1 1 0 minus 1 0 minus 1. Again we have 0 minus 2 2, 0 minus 2 and 2. What we'll do, I think first we will sort the array like we all are doing the same. We all from the initial days we are doing the same thing. We will sort the array and yeah, so we will sort the array and the array will become minus 2, minus 1, 0 0, 1 and 2, 1 and 2. So now after that what we will do, we will take I two loop I and j, and for three loop then the k will be from here and it will go from the while condition, like though two are the for loop and one is the while loop. Like we have seen that we are using while loop. For you can use for loop, but generally we use the while loop while doing any questions from two pointer. So we will take I here, j here, and k is from this to this, and k and l from this to this range. Okay, and we will check. We will sum two number. We will sum these two, and I will be here. K will be here, l will be here. We will sum I, j, k, and l. If it will be greater than the target, we will move the l pointer, as we are all are doing the same thing from the first class. And if we get the smaller one, so we will move the l pointer, because l and I here is you using as a two pointer. I and j is simply the two for loop. We can't do anything with this one. We can only do the thing with the l and k and l. Okay, so the same thing, like if this part, for solving this part we use a two pointer, same approach that we are doing from the initial day. I think it's clear. And for I and j, the simply for loop. And from this we will get the answer. And as we said, we need the unique one, so we will use the set, a simple set function, and set stl, and it will you will get the answer. So let's see the code. So the code is like we have given. We short the array as usual. We are doing the same thing, and then we will take an vector, because we need to store the quadruple, and we have to return all the quadruple, the unique quadruple. So that's why we're taking the 2D array. Now we check if the numbers is smaller than 4. So we will return simply, because you don't have any number, you have the number array and you don't have 4 number in it. So how will make the quadruple? So that's why we are just returning this empty one. And now we will pick here the number I change a variable, like first I in my explanation I take I and j, but here I take k and l. K is from k for loop, simple for loop. L is k, simple for loop. I take minus 3 because we have to 3 step ahead. K will be 3 step ahead. Means what means like k will be here, so it can't go there. If the k comes here, so then where will we go I and j? J where be? J is the last one. No, j will exceed the index. That's why. Same way L are doing the same thing. Now we take I one step ahead from this one. Like if I j like k is here, L is here, so I will be from here. That is j plus one. Like k plus one, L plus one. Sorry, variable issue. Sorry, variable conflict हो गया है. So yeah. So now after that I check the break condition. If I is smaller than j, then the loop will run. Then I'll take sum and sum all this 4, and I use this to long if there is any underflow, if there is any overflow. That's why. So if we take the sum equals to the targets, we will just simply push it and then move the I pointer and j pointer to find the another quadruple. If it's smaller, we will simply I plus plus, and greater j minus 1. Now at last we will use the set function and push all the elements in the set function, and then again we will assign that set element to the our answer vector, and we will return the vector. Simply, this is the question. This is the simple approach. And if we see the time complexity, it will be O of n, O of n, and O of n. That's O of n cube. So we somewhat we are able to uh, optimize it. So it will pass all the test cases because we have 200 only, and if we do these 200 and 200, so we will get 10 to the power 6, and it will pass all the test cases. Ignoring 2 only, I will seeing this one 10 to the power. So yeah, so that's a simple thing. Now the second question that I am going to discuss is sum of square of numbers. Sum of square of number, we can solve it with the help of two pointer. What the question is saying, that we have given a non-negative integer, like integer is not negative, okay. We have to check, we have to find two number a and b such that it satisfies this condition, like a square plus b square gives us c. Like we have given 6 c. Oh yeah, means we have to return true or false. The answer will be in boolean because we have to check is there any number which satisfy that condition or not. If yes, then return true. If no, then obviously return false. Now, so we have given 5. So if we do 1 into 1 as a and b will be 2, so it will gives us 5, so then that's why it's returning 2. And if c is 3, so there is no chance of any a and b which satisfy that condition. So that's why it's returning false. So this is a simple question what it's saying. Now let's see the approach. What the approach is. Like like he had given sorry like here is given c equals to 5. So any number that a and b is obviously in between 1 to 5, because no number can exceed 5, because we need 5 here, okay. If a and b is greater than 5, so how it will possible that it will give satisfy it? It always be greater than c. So we want any number that is in small. We want two number a and b which is in between 1 to c. Not c. Yeah, means yeah c. So but we will not check all the number from 1, 2, 3, 4, 5. To satisfy or equals to c, we just need the number from 1 to square root of 5, that is 2. Only 1 to 2 we will get the number. Like you can see, we get 1. A is in between 1 to 2 and B is also in between 1 to 2 or equals to us. So, so what we will do, we will just take number 1, 2, 3, 4, and the last number will be the square root of C. This is the last number that will be satisfy the condition. We will not take whole number, it will increase our time complexity as well. So so we use the technique that if the number wants to be equal, it will be obviously smaller than 5, and how much smaller than, it will be in between 1 to square root of 5, okay. So we will take the number and we will check is 1 is satisfying. I will be here, j will be here, like square root of 5 is 2, j will be here. Here it will satisfy the condition, then there is no need to move I and j. If there is a no, if it not satisfy the condition, so what we will do, if the number like squaring a square, that is I square plus j square, if we do, and if it is greater than c, so then we will move the j pointer because j are pointing to the largest element, and to get the sum smaller we will need to move in the smaller side, so that's why we're moving the j. The same thing that we are doing from the from the last first lecture. And if we are getting the greater, then we are just moving the I pointer. The same way we will get any answer. If we find answer equals to c, then that time we will return true. If not, then we will return false after our coming out of the loop. So the same thing what I have said, I have done here. Like I just check I and j, and j will be from the square root of c. We don't need to check all the number from 1 to c. We just need to check from 1 to square root of c. Now the break condition is I equals to smaller than equals to c, j. Then check I. We will just store the a square plus b square and d variable, and we check if d is equals to 3. So yeah, it's a good it's fine, good. We get the answer, we will just return true. But if small, then we will move the pointer to get more valid or more greater number, which is as close as possible to c. Not close, we find the exactly one, but two. What to get the number, we just first we need to approach it. So we are just approaching it, and then definitely at last we will find that number. We are just moving I plus plus, and if small greater than j minus 1, and return false, because if it's come out of the loop, and this condition never come, this condition never to come, it means there is no number that will satisfy this question, this equation. So we are just moving return false. So yeah, see the simple thing. And if we see the time complexity, so it's simply we are using O of n, one for loop, one while loop. So its time complexity will be O of n, and like, okay. So time complexity will be O of n, and space complexity is, we are not using any space. The space complexity is constant of one. So yeah, simple efficient solution, and it will pass all the test cases. It will very efficient one. So yes, this is a simple question, like how we can use the two pointer and solve the questions in an efficient manner. These two questions I have to discuss in today's lecture. So I have discussed. If you like my video, please like, share, subscribe. Thank you.